Okay, in this video, I'm going to go through the 2.6 homework on transformations. So this is all in your textbook, which I strongly encourage you to read in addition to our notes. So start out saying just describe the transformation. So I say, suppose the graph of f is given. Okay, so that's just, let me just get my pen going. That is just f of x, okay? That's given. Describe how the graph of each function can be obtained from the graph of f. Okay, so this is the new graph. So what is that? So you're going to take your f of x function, and this is a vertical translation. You're going to go down 1. And that is because I have right here, I have a -1 away from the function. So that's vertical, either up or down. Remember, vertical is exactly what you think. Okay, let's move on to the second one. Now look at the difference here. When you look at this one, you see how the x is inside where it should be, but the -2 is also inside. So that means that this translation is going to go either this way or this way. Okay, it says negative. In your brain, you tend to say it's going to go left because it says negative. However, because it's x and it's close to the x, it's the opposite of what you think. So this is actually right 2. Okay, let's keep going. Okay, here you have the change again inside next to the x. It appears to go to the right. It's actually going left 5. Now we're back outside. Make sure you can see the difference between 8a and 8b. 8b has +4 outside the function, so that means you're going to go up 4. Okay, outside the function is vertical, up and down. Horizontal is inside next to the function, and that is right and left. Okay, so now we have 2 changes. So let's identify each one. This change is next to the x. It's inside with the function. Therefore, that's going to go left 3. This other change is outside the function. So that's going to go up 2. And you have to memorize these, at least have an understanding of them so that you can call up the same information. Okay, next one. This is the B part. Once again, if the change is in next to the x, you're going to move horizontally. It's going to be the opposite of what you think, so it's going to go right 7. And then the next change is outside, therefore it's vertical, it says negative, and you go down 3. So those are all the changes, and you can write them just the same way I just did. Okay, so now it says, explain how the graph of g is obtained from the function. So how is this different from the previous problems? Well, for one, I actually don't give you a generic function. I give you a parent function. So that is the squaring function or the parabola. So if you start out with the parabola, this question is asking what change happens here. So because your change is inside next to the x, it's horizontal, and you're not going right, you're actually going left 2. Okay, so that's how it's obtained. So I gave myself a little sketch. So I said, okay, if this is my parent function, I am going to take that and move it to the left 2. That's my new function. Okay, and I got it by going left 2. Okay, next thing. Let's see what happens for b. So for b, it says x squared. Okay, so we have a nice x squared. So that's still that same parent function I just drew. Now you have a change outside. That change is going to be up 2. So again, what am I doing? I am taking that parent function, there it is, and I'm going to take it and I'm going to move it up 2. There's my new function. Okay, so we're starting to get ready to graph. Okay, here comes another one. If I have f of x is the absolute value of x, that is the parent function that looks like this. Okay, so absolute value looks like this. And again, I'm not graphing it, I'm just kind of sketching it because I'm not identifying points. We're going to do that later. So what's happening here? This is a change inside. So that change is moving to the left 2. Okay? Here's a change outside. That change is moving down 2. So what's this going to look like? Well, take your parent function. I'm going to move it to the left 2 and then down 2. That means right here is my new vertex, and that's my function. Okay, so you've got to know these parent functions like the back of your hand, because otherwise you're going to get yourself all confused and you won't know what you're doing. And you also have to know these transformations. So what's happening here, same as what we just did. So I'm definitely going to the left 2. But then look how this one's a little bit different. That's going up 2. So let's do the same thing. Here's my little grid. Now, I didn't ask you to graph these, but I personally think visually it's a good idea to get as much exposure as you can so that you understand it in a couple of levels. Okay, so what am I going to do? I'm going to take that vertex, which is where the V is, go 2 to the left, but then go 2 up. So go left and then go up, and here is where you are. Okie doke. All right, let's continue going. Okay, so now I'm going to ask you to start graphing things. And it says, use the graph of y equals x squared. So notice that is not a suggestion. That, my dears, is a command. So use that graph. So if I know, I'm going to do all my parent functions in red. Okay, so this is my parent functions. I need to have parent functions. I'm going to graph them. If my x is 0, my y is 0. If my x is 1, my y is 1 squared, which is 1. My x is negative 1, my y is negative 1 in parens squared, which is 1. If I have a 2, 2 squared is 4. If I have a negative 2 and I square negative 2 in parens, I would get 4. So this is a good time to mention to you that you cannot use a graphing calculator for this assessment when we have it. You can use a 5-function calculator if you really need to, but you can't use a graphing calculator. Okay, so what am I going to do with these points? Okay, I have 5 points that I've nicely labeled. I'm going to move things up. So every point, I'm going to do this in, let me do it in brown. Every point goes, this is what? Up 1. So this vertex goes to here. The left point goes to here. 2 left goes to here. The 1, 1 goes up 1. And the 2, 4 goes up 1. Then you just play connect the dots, and you should have the image of the same shape. Okay? Okay, next one, it's the same function, so let's just plot that. So I'm using the same points that I just used. Remember we said we want to aim for 5 points? So those are the actual points. Let's change to green this time. What is this telling me? I am going to the right 1. So let's take every point and move it horizontally by 1 unit. Horizontal movement to the right. There you go. Okay, that's the next one. Okay, so same function. Let me get my red out. And this is 0, 0. This is 1, 1. And this is 2, 4. Have it. Okay, that's the parent function. Now we've got 2 changes going on. So this one says, move it to the which direction? It's in next to the x, so it's goofy. That's going to go to the right 1, and then this other one is outside, so that's going to go up 3. Okay? All right, so let's take a different color. Let me use blue. I'm going to start on the far left. I'm going to move 1 to the right and then up 3. 1, 2, 3. That's my first point. Start with the next point. Go 1 to the right and then up 3. 1, 2, 3. There we go. Vertex. 1 to the right, up 3. 1, 2, 3. That's my new vertex. 1, 1. Go 1 to the right, up 3. 1, 2, 3. I'm just going to go like that. And then the one I just circled, 1 to the right, up 3. 1, 2, 3. Okay, just a note about these shapes. You should be seeing symmetry. If you don't see symmetry, then you're going to have a problem, and you probably want to go back and rethink what you're doing. Okay, next ones. Now, I'm going to talk quickly, but you don't have to listen quickly. You can just hit the stop button and, redo what I'm saying. Okay, here is our parent function. I'm going to do it in red. 0 for y, 0 for x, gives me 0 for y. Pick perfect squares. Excuse me. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is not on there, so I'm just going to go like that. Okay, so that's fine what I have right there. Okay, so what is this transformation? It's inside next to the x. You are going not left, but right 2. So take every point, 1, 2, 1, 2, 1, 2. Boom. There you go. Okay, next one. Same idea. I have 0, I have 1, I have the square root of 4 is 2. That's my y value. Okay, so there we go. Now, let's analyze this. What's it telling us? This is outside, so I'm going to go up 1. Take my origin, go up 1. Take my 1, 1, go up 1. Take my 4, 2, go up 1. Connect the dots. There you go. Okay, now these can all have arrowheads on them. I may not always put them. That's okay. All right, next one. Same parent function. Now, let me just tell you one thing. How am I getting this information? Okay, what I'm doing is I'm saying I'm going to pick an x. I'm going to pick x is 0. Because you have to know about this function. Okay, so the square root of 0 is 0. Then pick another perfect square, like 1. The square root of 1 is 1. Then jump ahead to 4, because the square root of 4 is 2, and that's going to allow you to do that point. All right, let's see what our changes are. We'll go back over to blue. This is inside next to the x. So you are going left 2. This is outside. You are going up 2. Okay, so I'm going to my 0, 0. I'm going to go left 2, up 2. I'm here. I'm going to my 1, 1. Left 2, up 2. I'm here. I'm going to my 4, 2. Left 2, up 2, and I'm here. And there is the transformation. Okay, so hopefully you're getting the hang of this. Okay, now let's read these directions. That's another thing. Read the directions so you know what I'm asking you to do. And I went through this in class. So it says sketch the graph of the function by starting with the graph of the standard function. What does that mean? That is your parent function. So you have to know the parent function. Identify 5 good points and then apply transformation to these 5 points. Now I kind of did that last time and I wasn't really asked to. Now we're asked to. So you've got to get it going. Okay, this is the absolute value. So my parent function is f of x equals the absolute value of x. Okay, so that means if I put a 0 in for x, I get a 0 back. If I put a 1 in for x, I get a 1 back. If I put a negative 1 in for x, to get my y, I take the absolute value of negative 1, which is 1. Okay, then I'm going to go 2. I put a 2 in, I get a 2 back. I put a negative 2 in. I have to get a 2 back because this is absolute value. There are 5 points right there. I'm happy with those 5 points. Why not? So I did my parent function in blue. I hope that didn't confuse you. Let me do that line better. Okay, so parent function, I'll box off the parent function so you'll know that that's what's in blue. Okay, so then in green, I'm going to do this transformation. What is the transformation? Well, this is outside, so that's going to be down 1. Okay, so if I go down 1, what does that mean? That means that everything is going to go down 1. Down 1, down 1, down 1, down 1, down 1, boom. There you have it. Okay, those are all the down ones. Okay, next one. This is also parent function, so I'll do that in red. Okay, my parent function equals absolute value of x. So what does that look like? Same thing we just did. So I will not go through the explanation again. Okay, so there I have my parent function. I'm happy with that. Okay, I'm going to do maybe gray this time. What's happening here? Well, that 2 is inside next to the x. So that means the movement is horizontal. It says +2. I'm not going to the right. I'm going to the left because it's an x. Okay, so take all of your values and move them 2. So I'm going to left 2. 2 to the left. So 1, 2, 1, 2, 1, 2, 1. I'm going to do this for 2. And then 1, 2. Okay, there you have it. Shifting, translating to the left. Okay, keep going. Okay, what function is this? Okay, you all should be yelling. I can't hear you, but I'm assuming you are. And this is x squared. Okay, we'll do that as a red. So if I put a 0 in for x, I get a 0 back. If I put a 1 in, I get a 1 back. If I put a -1 and I square a -1, I get a 1 back. If I put a 2 in, I get a 4 back. 1, 2, 3, 4. And then symmetry tells me if I put a -2 in, I also get a 4 back. There are 5 lovely points in red. Okay, let's do green. And we're going to do this. What's happening? In next to the x, it says -2. That means I'm going to go not right, not left. Which way? So if it says -2, it looks like I'm going left, but I am indeed going right. Hope I didn't fake you out there. Okay, and then -4, I'm going down 4. Okay, so let's do all those movements. So I'm going to do both things before I plot my point. Okay, so my little red dot furthest to the left, I'm going to go right 2, 1, 2, down 4. 1, 2, 3, 4. I'm going to put a circle around that. So if you always start to the furthest point to the left, you will kind of know where to continue from. Okay, go to the next point to the left. Go right 2, and then down 4. 1, 2, 3, 4. Okay, go to the vertex. Go right 2, 1, 2, down 4. 1, 2, 3, 4. Okay, if you're doing it right, you should start getting some symmetry. So I have my second to last point. I'm going to go right 2, 1, 2, down 4. 1, 2, 3, 4. Okay, one more. That top point there on the right, I'm going to go left 2 and down 4. 1, 2, 3, 4. There's my symmetry. Here's my graph. Boom. Done. Okay, let's keep going. There's another one here. Oh, look, it's still one of our favorite functions. The parent function, f of x, equals x squared. Happy day. I'm not going to go through the whole explanation again. You can hear that if you want to just hit the playback button. 1, 2, 3, 4. Okay, that's my parent function in red. I'm going to go blue. And what's happening? Two things are happening. The +4 inside next to my x is going left 4. The +1 outside is going up 1. Start the furthest point to the left. go left 4, 1, 2, 3, 4, up 1. Left 4, 1, 2, 3, 4, up 1. At the vertex now, left 4, 1, 2, 3, 4, up 1. Okay, here comes some symmetry, I hope. Second to last point to the right there. Left 4, 1, 2, 3, 4, up 1. And then left 4, 1, 2, 3, 4, up 1. Okay, so there you have it. Play connect the dots, and you have your vertical translation. Okie doke. Okay, now we get to this. Okay, what I want you to do here is read the directions. It says graph the following transformed functions. Start by graphing the parent function in one color, highlighting 5 accurate points. Then draw the transformed function in a different color, again highlighting 5 accurate points. Okay, I'm going to tell you, when you draw this, I'm going to say use a t-table to get your points, because these transformations are harder to do. Okay, first off, parent function is going to be g of x equals x squared. Okay, as I said before, I'm not going to go through how to get these 5 points. So I have those, and then 2 goes with 1, 2, 3, 4. Here's my symmetry. Happy day there. Okay, so there's my 5 points. Now, I need 5 points for this as well. So what is this telling me? I have this change right here. This is a vertical compression by a factor of 1/2. So you're going to push it down. Okay, what I would do is I would pick, because you're doing a compression, I would pick exactly the same numbers that you pick for your parent function. So I'm going to start, let's see, I'm going to start at -2, and then -1, and 0, and 1, and 2. Okay, I'm picking those because I know I'm just taking that function and squishing it down. I'm not moving it to the right and to the left, and therefore the x's I pick can be exactly the same, and they should be exactly the same. Okay, so now what you're going to do is you're going to take the -2 and you're going to square it. That is 4. It is not -4. Okay, you're squaring it in those parens. So then it says -2 squared, +4, times 1/2. That is like dividing by 2. So that's going to be 2, whereas before it was 4. Okay, -1. When you square a -1, it's also 1. 1 times 1/2 is 1/2. Okay, when you square 0, you still get 0. And you multiply 1/2 by 0, you still get 0. So when you press down, you do not change the vertex in this situation. Okay, I'm going to have symmetry now. When I square 1, I get 1, and 1/2 times 1 is 1/2. When I square 2, I get 4, and 1/2 times 4 is 2. Plot these 5 points. I didn't say move anything. I said plot these 5 points. Okay, so this is -2 and then up 2, right? Because that's -2 for the x. That gives me 2 for the y. Then -1 up only 1/2. I'm going to go right there. This is the same. I have symmetry right here, so that's going to be 1/2. And I have symmetry here. That's going to be that. So this is what's happening. I have pushed it down, and my graph is short and squat. Okay, if that had been a 2 instead of a 1/2, I would have pulled it up, and it would have been tall and slender. Okay? All right, here are some changes. I mean, to think about this one. The parent function, okay, the parent function is f of x equals absolute value of x. Go ahead and get yourself some nice points for that. And I'm trying to think, did I do anything funny for this? No, I think I'm going to just get the same points. Maybe I'll go bigger, because sometimes it's easier. Okay, so here I have that. If I have a positive 2, I get a positive 2. If I have a positive 4, I get a positive 4. Okay, that just gives me a little bit more space. You don't have to graph it like this. You could still use numbers I used previously. But this gives me just some more space. Okay, so did I do that correctly? Let me just quick look. That's 2. That's 4, right? That's negative 2. That's negative 4. Yep. Okay, so here's your parent function, absolute value. Okay, now I've got lots of things going on here. So we're going to have to think about numbers that I'm going to choose. What I see is I have many things going on. Let's list them. The negative in front is a flip over the x-axis. So you should check your notes on this. Okay, that's the first change right there, the negative in front. Then you have a 2. The 2 is a vertical stretch by a factor of 2. Okay, that's the second change. Notice that the flip, the negative sign, is not related to the stretch. It is separate from it. Okay, the negative has an impact, and then the 2 has an impact. They don't connect those impacts. Okay? Next one, it says x minus 2. That means I'm going to go to the right 2. And then it says plus 3. I'm going to go up 3. Okay, so I've got to do all of these things to those points. That would be tough. What's a lot easier is to start thinking about where this is going to be. So let's just think about this. I'm going to change to my other little thing. If I'm going to move this to the right 2, I'm going to be over here someplace, right? And up 3 is going to be here. Flipping it's going to be upside down, and then it's going to be stretched. So I'm thinking that I kind of want numbers over here in this quadrant. So once I start thinking along those lines, I'm now going to get a t-table going. So I cannot stress enough that this is a key point. So I'm going to start picking some numbers that are easy to work with. So I started out with a 4. So look, I can do 4 minus 2. Okay, 4 minus 2 is 2. 2 times a negative 2 is a negative 4. Negative 4 plus 3 is a negative 1. You've got to understand how to plug that in. So then I'm going to go another point. I'm going to go for a 3. 3 is a good number to work with because I'm keeping the numbers small. Okay, don't go crazy with your numbers. Pick numbers that keep it manageable and on the grid. I plug in a 3. 3 minus 2 is 1. 1 times a negative 2 is a negative 2. Plus 3 is a positive 1. Okay, that's like a good number. Okay, I definitely want to use 2 because that'll make things a 0 inside the absolute value. So 2 minus 2 is 0, and 0 times anything is still 0. And then plus 3, that was easy enough. That's a 3. Okay, I need 2 more points. I'm going to head in the same direction because it's going well. So let's put a 1. 1 minus 2 is a negative 1. But the absolute value of negative 1 is 1. 1 times negative 2 is a negative 2. And negative 2 plus 3 is a 1. Okay, I think I'm seeing a vertex appearing, and I'm going the other way now. Okay, keep going. I'm going to pick a 0. Okay, so I have 0 minus 2 is negative 2. Absolute value of negative 2 is 2. 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. Those are 5 nice points. Let's plot them and see what happens. Okay, so 4, 1, 2, 3, 4, and negative 1. So we do that again. 1, 2, 3, 4, negative 1. That's the first point. 3, 1. That's the next point. 2, 3. That's another point. Then I have 1, 1. Okay, I see some symmetry, so I think I'm doing this correctly. And then I have 0, negative 1, more symmetry. All right, there it is. That's my curve. Now, does that look like you have moved it to the right 2 and up 3? That looks good. Does it appear to be flipped over the x-axis? It must have been. And is it narrower than the original? And the answer is yes. So everything seems to be consistent with what I'm seeing in my transformed function. Okay, keep going. Okay, here's another one, and then we're almost there. Yep, we're almost done. Okay, so here we go. Look at this one. What's my parent function? My parent function is going to be a parabola. So I'll do that in red. So that's going to be here, 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 and then 2 and 4. 1, 2, 3, 4. Okay, I'm happy with that, happy with that. Okay, so when I have all these changes, if I just have a vertical and a horizontal shift, you can move the points of your parent function. When you have stretches and vertical flips or compressions, it is better just to graph it so that you can get your transformed function that way. Okay, what kind of transformation are we looking at here? Okay, the 2 is a stretch, vertical stretch. So I'm going to say vertical stretch. And it's by a factor of 2. That means whatever y is, you're going to multiply it by 2. Then I have x plus 1. So I'm going to go to the left 1 and then down 4. Okay, so if I'm going to make it taller, go to the left 1. So that's going, kind of moving it this way, right? And then down 4. So what kind of numbers do you think you want? I can probably stay, well, let me think about this. So you're going to be where when you graph it? It's going to kind of be here, right? It's not going to be way over here because of the fact that you're moving it to the right 1. So you'll have some numbers that will be there. But why don't we say, okay, if I move it to the left 1, that means that this number is going to be here. So let's kind of pick numbers that deal with that. Okay, so if I'm going to move to the left 1, what x is good to pick? So let's think about this. So I'm going to draw my little t-table. So moving to the left 1, previously I finished at negative 2. Why don't we pick negative 3 to start? Okay, and then let's just go negative 3. That'll be over 1. Then I'm going to go negative 2, negative 1, 0, and 1. So I think that will capture a pattern for me. Okay, plug in a negative 3. Let's talk about this. Negative 3 plus 1 is negative 2. Negative 2 squared is positive 4. 4 times 2 is 8. Uh-oh, getting big. Oh, but 8 minus 4 is 4. That was a good pick. Okay, negative 2 plus 1 is negative 1. Negative 1 squared is 1. 1 times 2 is 2, and 2 minus 4 is negative 2. Okay, negative 1 is my favorite right now because if I plug in a negative 1, I get a 0 in the parens. 2 times 0 is still 0, and a minus 4 is still a minus 4. Okay, plug in a 0 now, and you're going to get a 1. 1 squared is 1. 1 times 2 is 2, and 2 minus 4 is negative 2. Now, do you notice I'm doing PEMDAS? Okay, I'm doing the minus 4 last because PEMDAS tells me I do addition and subtraction last. But what do I do first? P in PEMDAS is parentheses. That's why I'm starting there. Okay, so all your math history from the past is coming back to help you do this. Okay, I plug in a 1 now. 1 plus 1 is 2. 2 squared is 4. 4 times 2 is 8, but I'm not nervous, so then I'm going to go down by 4. That's going to be 8 minus 4 is 4. I've got 5 numbers. Let's plot it and see whether that's going to work. So I start with the negative 3. So 1, 2, 3, and then up 4. 1, 2, 3, 4. Oh, that looks pretty good. Oh, excuse me. That looks great, but I went the wrong way. Hopefully you're yelling at me, because sometimes I need that. 1, 2, 3. Hold on. 1, 2, 3. 1, 2, 3, 4. Okay. So hold on a second. I'm not. What am I doing? I am doing this. I'm moving the points. I'm not moving the points. I'm just plotting the points. Okay. So 1, 2, 3. 1, 2, 3, 4. That's my first point. Minus 2. Minus 2. That's my second point. Minus 1. Minus 4. 1, 2, 3, 4. Third point. Oh, I see a parabola coming. 0 is minus 2. And 1 is positive 4. Symmetry I was looking for. Okay, so here's your transformed parabola. Does it look like it's stretched? It does. Is it moved to the left and down 4? Look at the vertex. Yep, that looks good. And is it, and that's it, right? So yeah, I think we've got it. Okay, so you always want to have that reasonableness test. Do the transformations I've identified, do they match up with what I'm seeing? And if not, just go back and redo your reasoning. Okay, but don't just think, oh, I hope that really works out, because sometimes it's not going to work out, because you have to rethink it, and that's totally fine. Okay, let's get the parent function here. So remember, this is the square root, so I need a good squared number. That's 4. 1, 2, 3, 4. And square root of 4 is just 2. And that's what the parent function looks like, okay? So now I'm going to figure out, all right, I only need 4 points here, so I guess I could do another one. So well, that's okay. I'm fine with the parent function having 3 points. Okay, now let's talk about what the changes are. It says I'm going to have a negative in front. That's a flip over x axis. Then it says plus 1, so I'm going to go up 1. Okay, so it looks like the numbers I have here are probably good. So given that, because of how I'm going to move it, right? I'm just going to flip it and then move it up 1. So it's not going to really change my x values, right? So let's use the same x values that I would normally use if I was going to graph the parent function. So it looks like I may need 1 more. So let's just grab another one. What do you think? So I did 4. What's the next perfect square? It's 9. 4, 5, 6, 7, 8, 9. And the square root of 9 is 3. So let me count again. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that's a 4th point. All right, so now I know that I have picked 0, 1. This is 4 and 9. I'm going to pick the same numbers again because I think it's going to work out really well. Here's my x. Here's my y. I've chosen to pick 0, 1, 4, and 9. And I'm going to take the square root of 0 is just 0. Minus 0 is just still 0. Plus 1 is nice enough. That's a 1. Okay, square root of 1 is 1. Minus 1 plus 1. Ooh, that's really good. That's a 0. Square root of 4 is 2. Minus 2 plus 1 is minus 1. That's an easy number to plot. And square root of 9 is 3. Negative 3 plus 1 is a negative 2. So I'm happy with those numbers. Let's plot them in blue. So this is 0 and then 1. So that's here. And then I have 1 and 0. That's here. And then I have 4 and negative 1 and 9 and negative 2. So this appears to be a flip, right? And then am I moving it to the right 1? Yep, it looks like that, right? So I'm good to go. So yeah, I think everything looks good there. Right. So that's what you have for that function. I'm happy there. Let's go to the next one. All right, here it says, for a given parent function, the indicated transformations are applied. Write the equation that represents the transformed function. Okay, so let's think about this. I'm going to write it as f of x because it says f of x. It's a parabola. If I'm going to shift it down by 3 units, up and down is vertical, so that's going to be x squared minus 3, done. Okay, next one. I have the square root function. I'm shifted left. Ooh, that's going to be inside next to the x, but it's going to look like it's going to go to the right in the equation, right? So this is going to be f of x equals x plus 2 all under that radical. Okay, here's an absolute value. It says I have to shift it left. If I'm going to go left, then that's the minus direction. It's going to have to be plus 2, right? And then down 5. So that's going to be minus 5 outside. So this is inside first and then outside. So f of x equals, okay, inside is going to be plus 2. Outside is going to be minus 5. Okay. Next one's getting more complicated, but that's okay. We're up for the challenge. X squared is your parent function. Stretched vertically by a factor of 2. So I'm going to say 2 is on the outside. Shifted down 2 units, down. So outside is going to be minus 2. Shifted right to the right. So inside close to the x is going to be minus 3. Okay, let's put that together. Equals. Okay, so I have to vertically shift by a factor of 2. So that's going to be 2. Then I'm going to put a paren because I've got to say x minus 3. And then squared. And then minus 2. Okay? Now let me just think about that. Did I do anything wrong here? I'm going to go right 3. Yeah, I think I'm happy with that. Okay, next one. Look at the parent function says absolute value of x. Okay, shrunk vertically by a factor of 1/2. So 1/2 is in front of the whole thing. So if I start out with saying f of x equals, I'm going to have a 1/2 here. Left by 4 units. So that's going to be plus 4. Okay, so that means that in cozy next to the x, is going to be plus 4. Oh, and then a vertical reflection over the x-axis. Oh, that's kind of fun. That's your negative in front of all of it. Okay? Next one. 63. They give you a picture, and it says the graphs of the parent functions and transform functions are provided below. Okay, so in all of these cases, the parent functions are red. No, are blue. So let me change that. Let me go back, because you have to know what's the parent, right? So the parent's going to be blue. So you want to figure out what happened to the parent to make the red. So this parent is x squared. I'm moving along the horizontal axis this way by 2. So that's going to be negative 2 in close to the x. X minus 2. And you have to square it because that was the parent function. Okay, so look at the next one now. Parent function's blue. It looks like they're the same width, so there's no stretch. What am I doing? I am going, okay, I'm going to go to the left 1. So that means it has to be plus 1, but it's close next to the x, right? Then what else is going to happen? Once I go to the left 1, I'm going to go up 2, but that's outside. So that's it. All right, so that's the entire thing. So you're going to need to go over this really carefully. Remember, I told you to do this homework carefully and not to do it all at once because it's a lot to think about. You have to know your parent functions. You have to be able to graph your parent functions. you have to be able to identify the transformations and graph the transformations. Okay, that means sometimes if they're more advanced and you have things like flips and stretches, that you're going to have to be able to pick the 5 good points to work with by thinking about how your parent function is being transformed and picking X variables that will help you identify that transformation. Okay, so that's all I have for you. I hope this helped.